There is an island on the edge of Europe that was supposed to be the last pure stronghold of the Celts. The place the Romans never conquered. The place where an ancient bloodline was said to survive, unbroken, while the rest of the continent fell to empire after empire. For generations, that was the story Ireland told about itself, and the story the world told about Ireland. A Celtic homeland. A people descended in an unbroken line from Iron Age warriors who crossed from continental Europe, carved their language into standing stones, and held the island as their own for over 2,000 years, protected by the sea from the invasions that reshaped everywhere else. Then the genome was opened, and the unbroken line turned out to have several breaks in it, older, stranger, and more consequential than anyone expected. What researchers found inside the DNA of people carrying some of Ireland's rarest and oldest surnames was not a simple Celtic story at all. It was evidence of a population shaped by forces that arrived from directions historians rarely considered, at times far earlier than the word Celtic even makes sense to use. This is the story of what the genome revealed beneath ancient Irish surnames. Not a story about romantic isolation. A story about how an island at the edge of the map became a record of nearly every major population movement in Western European history. The conventional narrative rests on what is often called the Celtic migration model. According to this account, Celtic-speaking peoples originating in Central Europe, associated archaeologically with the Hallstatt and Latin cultures, spread westward and northward during the first millennium BC, eventually reaching the British Isles and Ireland. There, this Celtic-speaking population is said to have either replaced or thoroughly absorbed whatever earlier inhabitants existed, establishing the linguistic and cultural foundation, the Gaelic language, the clan system, the mythology, that would define Irish identity for the next 2,000 years, protected from further large-scale disruption by the island's geographic isolation. Surnames reinforced this framework beautifully. Gaelic patronymic surnames beginning with Mac, meaning son of, or O, meaning grandson of, or descendant of, names like O Swiliabain, Mac Carthay, O Concaber, were treated as living fossils of clan lineages reaching directly back into that Celtic Iron Age world, unbroken by the kind of foreign conquest that reshaped surname traditions elsewhere in Europe. It was a powerful story. An island, a people, a language, and a bloodline, all moving through history together, untouched. But archaeologists had already found evidence that complicated the timeline considerably. Ireland's monumental passage tombs, Newgrange among them, predate the presumed Celtic migration by well over 2,000 years, built by a Neolithic farming population whose language, beliefs, and ultimate fate remain only partially understood. That population did not simply vanish to make way for later Celtic arrivals. The stones remained. The question was what, if anything, of the people who built them remained too. Something in the deep timeline did not sit comfortably beside the idea of Ireland as a purely Celtic story beginning in the Iron Age. This is where genetics entered the investigation, and the picture began to shift beneath everyone's feet. Researchers analyzing ancient DNA recovered from Irish burial sites, including Neolithic farmers, Bronze Age individuals, and remains associated with the megalithic tomb-building culture, compared these ancient genomes against each other and against modern Irish populations, using autosomal DNA to trace broad ancestry alongside Y chromosome and mitochondrial DNA to follow specific paternal and maternal lines. What they were testing was continuity. What they found instead was rupture. The genetic profile of Ireland's Neolithic farming population, the people who built Newgrange, turned out to be almost entirely replaced by the time the Bronze Age began. A new population, carrying substantial ancestry connected to the same Eurasian steppe migrations associated with the Bronze Age transformation of much of the rest of Europe, appears in the Irish genetic record with startling completeness, arriving from the east via continental Europe and Britain well before the traditional dating of any specifically Celtic migration. That was not a minor detail. That was a signal the old timeline was not built to explain. If a story like this, an island imagined as the last pure holdout of ancient Europe, revealed instead to be a record of nearly every major migration that shaped the continent, is the kind of history that keeps you watching. Subscribing helps this kind of research reach more people who care about where their names actually come from. The deeper the ancient DNA record was studied, the less Ireland resembled an isolated Celtic sanctuary and the more it resembled a crossroads that simply happened to be surrounded by water. Several frameworks emerged to explain the layered picture the genome was revealing. The first involved the scale and timing of the Bronze Age step-related migration itself. Rather than the Celtic language and identity arriving as a single, culturally complete package in the Iron Age, researchers increasingly consider the possibility that the population movement most responsible for reshaping Ireland's genetic makeup happened centuries earlier, during the Bronze Age, and that Celtic language may have developed or spread later, layered onto a population whose genetic transformation had already largely occurred. The second framework centered on maternal versus paternal asymmetry. Studies of Y chromosome lineages in modern Irish men revealed an unusually high frequency of a particular paternal lineage associated with the Bronze Age migration, found at levels among the highest recorded anywhere in Europe. A pattern researchers associate with a demographic event involving a small number of male lineages achieving outsized reproductive success, whether through social dominance, warfare, or a founder effect following the original migration. Maternal lineages, by contrast, showed a somewhat more gradual, layered transition, suggesting the arriving and existing populations mixed unevenly across gender lines, in a pattern researchers describe with appropriate caution given how socially complex such imbalances can be to interpret. The third framework involved the traces of the earlier Neolithic population that, while genetically overwhelmed, were not entirely erased. Small but measurable proportions of ancestry connected to Ireland's original farming population persist in the modern Irish genome, suggesting a partial absorption rather than a total replacement. The builders of Newgrange did not disappear so much as they were folded, in fragments, into the population that came after them. None of these frameworks alone explains everything the data shows. Most researchers treat the true picture as some combination of rapid Bronze Age population transformation, uneven mixing between arriving and existing groups, and the quiet, partial survival of a much older Neolithic layer beneath it all. Then came the study that gave this story real scientific weight. Ancient DNA analyses drawing on dozens of prehistoric Irish burials, compared against a wide reference panel of ancient and modern European genomes, confirmed that the genetic shift between Ireland's Neolithic and Bronze Age populations was one of the most dramatic population turnovers documented anywhere in prehistoric Europe. The Bronze Age Irish genome carried a substantial proportion of step-related ancestry, arriving via a chain of migration that passed through continental Europe and Britain, fundamentally reshaping the island's population well over 1,000 years before the earliest reasonable estimates for the arrival of a specifically Celtic language. The evidence did not eliminate the Celtic story. Language and culture almost certainly did arrive later, through some combination of migration and cultural diffusion still debated among linguists and archaeologists. But the genetic foundation those Celtic-speaking communities were eventually built upon had already been established centuries earlier, by a population whose origins traced back to the vast grasslands of the Eurasian steppe, about as far from the romantic image of Irish isolation as it is possible to get. Here is the twist that reorganizes the entire ancient Irish story. Not the last untouched Celtic stronghold of Europe. Not a bloodline that simply arrived once, in the Iron Age, and stayed forever unbroken. What the genome revealed instead was an island shaped by at least two profound population transformations before recorded history even began. A Neolithic farming population that built some of the most sophisticated Stone Age monuments in the world, followed by a near-total genetic replacement during the Bronze Age by a population connected to the vast steppe migrations reshaping the rest of the continent, with Celtic language and identity layered on top of that foundation only later still. Not isolation from Europe's ancient upheavals. A front-row seat to nearly all of them, preserved with unusual clarity precisely because the island's geography limited how thoroughly later disruptions could overwrite what came before. This matters beyond Ireland, and beyond any single surname beginning with O or Mac. It challenges the romantic assumption, common to many island and peripheral nations, that geographic edges preserve purity rather than simply preserving evidence. Isolation does not stop migration from happening. It sometimes just makes the layers easier to read afterward, because fewer subsequent waves have blurred them together. Human history, even at the edge of a continent, was never a straight line protected from outside contact. It was contact, again and again, followed by long periods where the results of that contact had time to settle into what later generations mistook for an unbroken bloodline. Picture the Irish Midlands in late autumn, where the passage tomb at Newgrange still catches the winter solstice sunrise through a stone roof box engineered with a precision that startles modern visitors, built by people whose language is lost entirely, whose DNA survives only in fragments inside the population that eventually replaced them. Beyond the tomb, green fields roll toward low mountains wrapped in mist, fields that Bronze Age farmers worked using tools and techniques carried across the sea from Britain and, before that, from continental Europe and the steppe beyond it. Every hedgerow, every ring fort, every holy well associated with a saint whose cult absorbed an older, pre-Christian reverence for the same ground, sits on top of layer after layer of people who were here before, and whose presence never entirely left. What the genome revealed about rare Irish surnames, in the end, is not a story that diminishes Irish identity. It is a story that deepens it considerably. A family carrying a name like O'Swilliabane is not simply the inheritor of an unbroken Celtic Iron Age lineage. They are, more precisely, the inheritor of a Bronze Age population transformation that reshaped an entire island, itself layered onto the faint genetic memory of Stone Age farmers who aligned a passage tomb to the winter sun with an accuracy that still humbles modern engineers, all of it wrapped, many centuries later, in a Gaelic name that only tells the most recent chapter of a much older story. The old narrative was not wrong to call Ireland ancient. It simply did not know how ancient, or how many different peoples that word actually contained. The map called it Celtic. The genome calls it something closer to a compressed, extraordinarily well-preserved archive of nearly everyone who ever crossed the Irish Sea and decided to stay. Somewhere in Ireland today, a child is given a surname that sounds purely, unmistakably Gaelic, a name that will appear on a birth certificate, a passport, eventually a headstone in a churchyard beside a ring fort older than the church itself. Inside that name, and inside the genome carrying it forward, sits a fragment of a Neolithic farmer who helped raise a monument to the winter sun, a fragment of a Bronze Age migrant whose ancestors once grazed cattle on the Eurasian steppe, a fragment of language and memory whose true beginning no single record can name. The name draws a line back to the Iron Age. The genome draws a line back much further than that, into a past the name was never built to describe. If uncovering how much deeper an ancient bloodline can actually go, even on an island long imagined as history's last untouched refuge, is the kind of story that stays with you, subscribe, because Ireland is only one small, densely layered page in a much longer human record still being read.